So the next topic in trig transformations is for tangent. So we'll use the same variables that we did for cosine and sine, which is a, b, c, and d. The properties are going to be a little bit different. So the definition of amplitude is the distance from the midline to the maximum, which is particular to sinusoidal functions like cosine and sine. Tangent does not have amplitude because it's increasing indefinitely, right? Or not in depth, but within each period it is increasing indefinitely. It's monotonic, so it's always increasing. However, we will still have that stretch factor that we will call A. So that will still be your vertical dilation. So we can still stretch and compress tangent, but the A value is not going to represent amplitude anymore. It will only represent that stretch or that compression. So just keep in mind that tangent does not have amplitude because it doesn't have relative extrema. To find the new period, it will be a little bit different. So if you recall from the previous unit, the period for tangent is pi. So we'll use the same method. We can say that b is equal to old over new, but now your old is going to be pi instead of 2 pi because the period for tangent is pi. And then we can also see the new period is equal to pi over b. The phase shift will stay the same. It is shifting left or right, but for cosine and sine, we were able to use like maximums, minimums, whether it's increasing through the midline or decreasing through the midline. For tangent, your point of inflection is going to help you. So we'll see what that looks like in these next few examples. So using the point of inflection will help you find your horizontal translation. Your vertical translation, up or down, same thing. You'll want to use your point of inflection to help notate that. And then for tangent, we will still have vertical translations shifting that function up or down, but tangent has no midline. So the D value does not represent the midline, it just represents the vertical translation that we will see occur. So a portion of the function is shown. The function can be written as f of x a tangent bx plus d, where a, b, and d are constants. Find the value of a, b, d. Okay, so again, whenever we are looking at tangent, your go-to should be the point of inflection. So the parent function for tangent looks like this. It's going to increase and it's passing through the origin. And then we have our two vertical asymptotes at negative pi over 2 and positive pi over 2. So again, you have to know your parent functions. You need to know their attributes, you need to know what they look like, and you need to know their trends so that when we transform them, you're able to see them clearly. So we'll have A, we'll have B, and we will have D. So for the point of inflection, I can see that I have a point of inflection here. That's where the concavity is changing, and it's at 0, 0. This aligns with the parent function for tangent, which means we did not shift up or down, all right? The function is still having that point of inflection on the x-axis. Therefore, there is no vertical translation. So that means D is equal to 0. So now let's talk about the B value. We need our new period for tangent. The old period for tangent is pi. Okay. So the period or a cycle repeats at the beginning. The beginning of the cycle will repeat at the vertical asymptotes, all right? So we have a cycle here, we have a cycle here, and we have a cycle here. So we're looking at 3 cycles of tangent. If I look at this, I'm going from negative pi over 4 to positive pi over 4. Okay, so if I think about that total distance, I have a fourth on this side, and then I also have a fourth on this side. That means we have a period of 1/2, or in this case, pi over 2. You can also use the cycle on the right side. Pi over 4 to 3 pi over 4. 3/4 minus 1/4, you get 2/4, which is going to be 1/2. Okay, so that's not my b value though. So for b, we're going to use old over new. So since we're using tangent, the old period for tangent is pi, and then the new period for our tangent is pi over 2. So with this ratio, we want to ask, okay, how many times does pi over 2 go into pi? It goes into it twice. Or the other method is we can multiply with the reciprocal of the denominator. So we get 2 pi over pi, which is also equal to 2. So now for tangent, the amplitude is usually going to be a little bit more difficult, right? So the amplitude is going to be the vertical stretch or vertical compression. So it's our vertical dilation. So I'm going to go ahead and get rid of some of this so that we can have a clean slate. So if we think about our parent function, think about the key points for tangents, okay? So for tangent, we have 5 key points. We have the vertical asymptote as a key point, the point of inflection, and then the second vertical asymptote. We also had key points halfway in between those, okay? So in my parent function, I had negative pi over 4, we had 0, and then pi over 4. And the outputs were -1 and +1. So that means for tangent, if I think about the relationship between those 3 key points, whoops, that's incorrect. It should be down and then up. They will have a distance of 1 unit. So from the lower key point to the middle key point, 1 unit. From the middle key point to the upper key point, 1 unit. Okay, because we went from -0 or -1, 0 to 1. Okay, so it's always going to be 1 unit. So that's what I want to look for. So halfway in between, I want to see, did we stretch this beyond 1, or did we compress it to something smaller than 1? Now, graphically, if I look at this, if I were to split this interval in half, so I would be at pi over 8, it looks like it's passing through -1. That would be negative pi over 8. Same with this side, pi over 8. It looks like it's passing through 1. So how do we confirm this? Well, there's a couple ways to do it. Obviously, with the graph, I'm not sold on this because I need to see it. The numbers won't lie. I need to see, okay, analytically, will this work? So what I'm going to do is I'm going to steal a point. I know that here this is pi over 8 and then 1. So this is what I want. I want this to happen to show that my amplitude is 1. So I got pi over 8 because I'm slicing this interval in half, which is pi over 8 times 1/2. I'm sorry, pi over 4 times 1/2. We get pi over 8. Okay, so with my 2, I have my b, I have my d. So I have f of x is equal to a tangent bx plus d. I'm looking for my a value. I know the b value is 2, and I know the d value is 0. So what I can do is I can steal this point, and I can also plug that in so that the only variable that is left is a. Okay, and let's see if we can solve for that. So my input is pi over 8. So f of pi over 8 is equal to a tangent. My b value is 2, and then my d value is 0. Sorry, this is not an equivalent statement. My x should be pi over 8. There we go, plus 0. So f of pi over 8, I want an output of 1, right? So let's see. So we'll say 1 is equal to, we'll have a tangent. 2 times pi over 8 will reduce to pi over 4. And then we have the plus 0. Tangent of pi over 4 is in quadrant 1. That's going to be positive 1. Therefore, a is equal to 1. So it checks out. Therefore, a is equal to 1. All right. Example 30, the function h is defined by h of x equals 4 tangent 2x plus 5. What is the period? So we have 4, 2, and 5. We're only focused on the period, so we can ignore the 4 and the 5. The only thing that's going to affect my transformed period is that 2. So we have b is equal to old over new, which we can also say that new is equal to old over b. So for tangent, the old period is pi. So the new period, which is capital P, will be pi over whatever the b value, which is 2. So the new period is pi over 2. Or you can think of it as, since b is 2, we have a horizontal compression because it's a scale factor of 1/2. The old period for tangent is pi. So if we compress that by 1/2, we are left with pi over 2. All right, so let g be the function defined by g of x is equal to 2 tangent x over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g? Okay, so be careful with these. I know in our previous unit, we always notated using this. That is a domain restriction. That means the domain is all real numbers except for these values. But since we are now talking about vertical asymptotes, you still need to write equations for vertical asymptotes, okay? So the equation for the vertical asymptotes of tangent are pi over 2 plus pi k. And just a quick review, that's because we use the first positive vertical asymptote to start, and then they occur every pi, before and after that pi over 2, okay? So that is the equation for the vertical asymptotes for tangent. All right, so vertical asymptotes are changed by whatever is changing the domain, or the x values, hence the x equals, okay? So that means I only want to use the transformations that are changing the inputs. The 2 changes the range, the -1 changes the range, therefore I'm only worried about this 3. So I have x over 3, okay? That means my b is equal to 1/3, which means because it's 1/3, we have a horizontal stretch, aka a horizontal dilation with a scale factor of 3. So that means I'm going to change my vertical asymptotes by a scale factor of 3. So the new vertical asymptotes, I'll write new up here, or I guess I'll do g of x. We'll do g of x. So for g of x, your vertical asymptotes are x equals, I'm going to multiply the original vertical asymptote equation with a scale factor of 3. So we can distribute that 3. So we get 3 pi over 2 plus 3 pi k. Which makes sense because if our original vertical asymptote is at pi over 2, we are stretching that by a factor of 3. So now it's starting at 3 pi over 2, and instead of occurring every pi, it will now occur every 3 pi because that is our new period. The period now has a length of 3 pi. So that means it's C. Example 32, a portion of the function k is shown below. Which of the following could be the expression for k? Okay, so these are all tangent, but once we start seeing, in the next unit, we're going to start seeing tangent and cotangent, so some of the multiple choice could change as we move forward, and you'll see why later. So we are looking at 3 cycles, okay? I see 3 unbounded lines increasing indefinitely in between vertical asymptotes. So the first thing that you should look for is your point of inflection, and that's going to be where the concavity changes, which will be here. So I can see that my point of inflection was shifted off of the original x equals 0. I'm sorry, y equals 0, okay? And it's shifted down by -2. Therefore, your d value is -2 because we have that vertical translation of -2. That means we should see a -2 here, so we can exclude B and D from a potential choice. So luckily, we don't have to worry about amplitude, right? They are the same, it's just 1. Sorry, not amplitude, the vertical dilation. Tangent does not have amplitude. I need to get out of the cosine and sine topic, okay? So with this one, we need to look at our B values. And to get the B value, we need that new period because it's out with the in, old with the new. Whoa. Out with the old, in with the new. Doing too many videos at once. Okay. So with this one, we can use the asymptotes to find what the new period is. So here I see an asymptote at pi, and then I also see an asymptote at 3 pi. So that tells me from pi to 3 pi we have 1 cycle, which means our new period is 2 pi. So we stretched out tangent. So the old period for tangent is pi. Our new period is 2 pi, which means we get 1/2. So the answer is A. Now, you did not have to use that formula. If you see that it's 2 pi, you're like, oh, okay, so we have a horizontal dilation with a scale factor of 2. Therefore, I should see a 1/2 in my function rule, or 1/2 as my B value. So that's why it would be A. This would be a compression with a scale factor of 1/2. All right, that's for tangent. Hope this helps.